record on the computer. All right, so hello everyone, and welcome to GDV's week 2, the first lecture for this week. So this week we're going to go over some intermediate scripting stuff. Later on Wednesday, we'll be focusing on our state machines. That should be after you guys have done some of these featured analysis and started messing around with the state machines. Let's go ahead and take a look at some of the topics we will be covering. So we're going to be covering inheritance, polymorphisms, member hiding, and extension methods. We're going to skip those as normally programmers are going to be using those more. They're really for niche operations that as a game designer, you're typically not going to run into. In general, you're not going to run into these. We'll be talking about overriding, and that really goes hand in hand with inheritance. Interfaces, which we've touched on before in PGF2 in Unreal. You may not have been exposed to it in Unity yet, but we will be going over that. And namespaces. So namespaces you've been using, but today we're going to show you how to create your own namespace. So without further ado, let's go ahead and get started. Let me open up Unity. So this is a scene that you'll start to see this week coming up. And kind of like last week, we have this nav mesh agent. He just goes around from point to point to point. So you guys should have seen that already, I believe. So what we're going to do right now is we're going to talk about inheritance. And one of the best ways to show inheritance is with pickups. So if you remember back in PGF2, we had a bunch of pickups and we started from a base pickup. And we extended and we made a damage pickup, and we also had an ammo pickup. And optionally, if you chose the optional works, we had health pickup and speed pickup. Those were 2 options that you could have done as a student in PGF2. Now, the reason that we choose pickups for inheritance is that they're a really good showcase for it. Another good example of where we would use inheritance is enemies. Right, we'd have a really basic enemy class, and we can divide the enemy class down into 2 general major classes, which would be melee and ranged. And we can subdivide those even further and have different types of interactions that they would do with the player based on how we as designers choose for them to act. And that would be all programmed, and the stuff that's shareable would be up in the parent class. So let's go ahead and get started on creating some base pickups. But before we do that, we actually need to make a player character. We want somebody to be in here and interact. So first, let's make a player character. So let's go in here and we'll use a capsule. Let's rename the capsule. It'll be player. Now, you may not have seen this before, but we're going to use a new component. I'm going to use a character controller. There it is. So now this character controller is really nice. It allows you to mess around with some things like slope. So what kind of slopes this player character can walk up, steps, offset, and there's a bunch of other things as well, height, radius, center. It has a lot of nice functionality. Another thing that it does is it has its own collider. So we don't need this collider anymore. So we can actually remove it. And you'll see that green line. And let's see. Let's get closer to the character so you can actually see it. As you can see, it still has a collision. So the character controller already provides it. And it provides some of the nice things that we get in rigid bodies as well. And give me a second. Let me get this character down on the ground. My middle mouse button is freaking out, so I'm having to use some of these old keys that I haven't used in a long time. So bear with me on that. Okay, my character is way too small, so I want to bump him up. That might be a little too big, but we'll just go. All right. So we also want to add a script to him. So let's go ahead and make a script. C sharp. I want a new one. C sharp. Fine. Doesn't want to be nice to me, so I'll just do it this way. I'm just going to call this player script. So in the player script, we're going to want him to move around. All right, and so we're going to want to set his speed. So what I'm going to do is make a serialized field, just in case we want to change it. We don't actually have to come back to the script in order to change his movement speed. We can do it right from Unity. And so you should have been already exposed to, serialized fields before, but in case you haven't, all this does is it exposes this parameter in Unity, and I'll show you. So saving it. Actually, did I do this in the right thing? No, this is my nav point. So we don't want that there because that's the nav point. Let's go back to Unity and let's open this up. So this is the player script. And we want to put in the serialized field here. Oh, nope. And we'll just start with 5. So here, did I save it? Well, all right, so we have movement speed we're going to be working with. And over here in Start, let's get our character controller. And we're going to do that using the getComponent method. Actually, let's define the variable that we're going to use. Our character controller is just going to be called CC. Character controller, CC. Now before, we're going to actually initialize this to null so that we don't get the warning. And now we're going to get CC. So we're going to use the getComponent. And we're going to be looking for the character controller. So here we're getting the character controller and we're storing it in this variable CC because we're going to be using that later on in update. So one of the things that's really nice with our character controller is that we can actually, by default, use WASDA to get some movement. It has some movement-based stuff or functions already set up. So one of the things is move. Another one is simple move. So simple move is what we're actually going to use. And with simple move, we can actually just pass in a vector and the character will start moving in that direction. But in order to do that, we first have to make this vector. So first, let me comment this out. And we're going to create a vector 3. And it's going to be move direction. We'll just use move dir. And we're going to get our access. So input get access. And for the first one, we want our vertical axis. So we're going to actually just type in vertical here. So what this is going to do, if we hit W, it's going to give us +1. If we hit S, it's going to give us -1. If we were on an analog controller, it would give us a value between -1 and 1. Now, for right now, we also need to have a direction, right? So we know that we're getting 1 and -1, but which direction? So in order to do that, what we're going to do is multiply it by our forward transform. So that gives us one of our movement directions. So currently we're dealing with forward and backwards, or W and S. We also want to have our left and right. And when we combine them together, it will have a directional movement. So let's do that. So what we're going to do that is we'll use the same variable that we have. This is a vector3. We're going to add to it. We're going to get our horizontal axis. So we'll use input.getAxis. And this time we want our horizontal axis. Make sure I spell this right, because if you don't, it's not going to work. Now, again, we have to, it gave me the extra one. We also have to tell it what the direction is. So we're going to use transform.right. So this is our right vector. So now if we use the CC simple move, we can pass in our vector3, which is movedir, and we will get the direction that we're moving. However, that's going to just pass in 1, right? So if we hit W and A, it'll move 1 unit forward and 1 unit to the left. We don't want that. That'll be really slow. So we're going to use that movement speed variable that we created. We'll multiply that in there. Now, if everything is working well, we should be able to move around in the game. Let's see, we have an error. So I messed up something here. Nav point, oh yeah, this is when I was, is it? No, that's the wrong language. I have too many of these. Nope, I see. The error is I took out one of these. And I don't need that extra one. So yeah, that happened because I deleted out a little bit too much when I was trying to get rid of that serialized field. All right. Got some warnings. We'll take a look at those later. But let's see. Can we move around? Yes. And he feels kind of slow at 5. So let's stop playing. Here's our move speed. Let's actually bump that up to 7. That's that serialized field that we put in there. See how he feels now. So yeah, I like this better. So we'll leave it there. Stop playing. All right, so now we have a character that'll move around and he can interact with objects. So next, let's actually make some pickups. So we're going to make the base class of pickups. And we're just going to call it pickup base. Seems like a good name for it. So let's create a new C# script. And it's going to be called pickup base. Oh, I have some more guests that need to be added. So So for those of you that are just joining us, so far what we've done is we're going over inheritance, and we're going to be creating some pickups to showcase inheritance. Currently, all we've done so far is create a player character. On the player character, we added a character controller, and in its player script, let's close that down. I have too many of those up. In our player script, we went ahead and got the component, got the accesses by using input.getAccess vertical and horizontal, and multiplying them by our character's forward and right vectors, and used a method that exists on the character controller called simple move. And we passed in our vector3, which is movement direction, and we multiplied it by the movement speed. And all that did is allow the player character to move around in the scene using WASDA. So next we're going to create a base pickup. And this is going to be our parent class. Now, one of the things about parent classes is that if you remember back in PGF2, we try to keep them as minimalistic as possible. They should only ever have the functions that all of the children are going to share. Sorry about that, I was reading the chat log. Yeah, so thanks, Thomas. I just now realized that you gave me the answer for before. But to get back to this, only the shared functionality should be in the parent. So one of the things that we're going to be doing is we're not going to reuse start and update. So let's get rid of those. Now, inheritance, you'll notice that our base pickup class, this is the one that we're going to define now, it's inheriting from mono behavior. Now, mono behavior is something that Unity created and has a whole bunch of functionality that we can access. So that's so far the inheritance structure is base pickup inherits from mono behavior. Now, we're going to want an on trigger. And basically, what we're going to do with this on trigger is we're going to check to see if it's if the character that is colliding with it is a player character. And if it is, for right now, we're just going to have it destroy. So if the player walks over this pickup object, it'll just destroy the pickup object. So let's do that. We'll do that by using an if check. We're going to check if this other object right here, we're looking at this collider. We're going to, since we have the collider, we need to get a component. We need to check to see if this is the player character. And the way we're going to do that is by looking for the script. Do we have the player script on this object? If we do, then we'll go to another method that we'll create, and we're going to call it doPickup. And we actually do want to pass in, we're going to pass in the other character. This should be the player object. Now, right now we're getting this error because doPickup doesn't actually exist yet. So let's come down. And for right now, we're going to create doPickup. We need a return type. It's not going to return anything. So void doPickup. And it does have some parameters that it inputs. It's going to take in a game object. It's capital G. And we'll call it GO for game object. Now for right now, what we want to do, and the only thing we're doing for right now is we're going to destroy the base pickups game object. So whatever the script is attached to, we want to destroy that. And to do that, we have to use game object lowercase g, because this is the actual game object. This is the class. So let's save that. We have an error here. That's right. So we're getting this error because we're passing in other. Other here is a collider. And this is specifically asking for a game object. So in order to get the game object for it, just add on dot game object. So now let's make another object just for testing. We use a lot of spheres. Let's go ahead and use a cube. And we'll call this cube base pickup, because we just want to use it to show the functionality of pickup base. So it's kind of hard to see on, oh yeah, there it is on the map. So let me go ahead into my materials. I made a bunch of materials. I'm going to go ahead and use the puppies materials. Let's see, just use this one. Let's use. All right, so now that it's blue, it's kind of small too. Let's bump it up. And let's actually put it down where it's going to collide with everyone in the world. So I'm going to hit play first, and I'm just going to let this nav agent move around. All right, it didn't actually touch it. Let me go ahead and move it to where the nav mesh agent is actually going to collide with it. So I'm just checking to make sure that my check is working, that the nav agent doesn't make this thing destroy. And right now it blocks it. Now there's a reason for that, and that reason is I didn't tell this to be a trigger. So over here in box glider is trigger. Got to check it to be true. If that allows rigid bodies to pass through it. So there's some weird behavior that you saw there, and we'll fix that later on. That has to do with how the nav mesh is calculating where it's going to move to. But as you see, this pickup didn't actually disappear. Now with the player character, let's go ahead and touch it, and it does disappear. So that is functionally working as we intended to, for now anyway. So that's good for the base, but I want to showcase inheritance. So if we remember way back in PGF2, we had our base pickup class, and then we made a damage pickup. But I don't want to do a damage pickup. We've already done a damage pickup. So I actually want to make one called puppies. All right, so we're going to have it. It's going to be called pickup puppies. So pickup puppies. Now, as you can see, by default, whenever we create a new script, it'll default to inheriting from mono behavior. We don't want this script to inherit from mono behavior. We want it to be a child of our pickup class, or pickup base. So we do that just by deleting mono behavior and putting in pickup base. So we don't need any of these. As you know, as you can see, there are no functions here. I'm going to save it, and I'm going to attach it to this. Let's remove this, and let's go ahead and put pickup puppies onto it. So as you can see, pickup puppies is now on there. Pickup puppies doesn't have any scripts. But when I come here, We'll play it. It still disappears. And the reason for that is because pickup puppies inherits from pickup base. So everything that pickup base does, pickup puppies will do. Now, I don't want it to be an exact copy of pickup base. That'd be sort of a waste of time. I want it to have different functionality. So one of the things I'm going to want to do is override. Let's go back onto here, and overriding is one of the topics we'll be covering over. So to override a method, I want to override this doPickup method, and we'd use the keyword override. And right now, as you can see, there's only 3 things that we can override. Now we have equals, get hash code, and toString. These all exist in mono behavior, which is why we can override them. doPickup, as you see, isn't on the list. And that's because we actually haven't told doPickup that it can actually be overridden. In order to do that, we have to use a keyword, and that keyword is called virtual. Now, if we left it like this, let's leave it like this. Actually, it won't let us, because right now it's complaining that this is a virtual abstract member, and by default, remember that we have these protection levels, private. If we don't actually put anything in the front here, we don't actually specify what the protection level is going to be, C# will default to private. And private means only the members, the methods in the script can access that particular method. Since this is a child, we can use one of 2 others. We have protected, which is one that you guys probably haven't used too much. Now, what protected does, it allows base pickup, so that class, and any of its child classes to access that method. If we use the word public, which is the 3rd of the protection levels, we will allow any other script to access that method. When you are coding, it is the best practice to use the highest protection level that you can. So since base pickups are only going to be, only children of base pickups are going to be using this doPickup method, we're going to use protected. So now the errors go away. And if we go back to pickup puppies, we still have this keyword override. Let's go back, override, space. And here we are, we have doPickup. It shows up in our list. Now, whenever we create one of these override functions, it will always come in with this base dot method name. Now, what this is telling us is that it will, by default, do whatever is in this method. So whatever is in between these curly braces, by default, it's going to do. So I don't want to destroy puppies. Actually, no, we will destroy puppies. We won't destroy the next pickup that we make. But for right now, I want there to be some type of different functionality. So let's go ahead and do a debug log. And we'll just send out a message and we'll just say, we're playing with puppies. So let's save that. Let's go back and just ensure that it's working. Let's go ahead and bring up the console so we can actually see it. Clicking in the wrong thing. And as you can see, we get playing with puppies and it destroys it. So let's make another pickup. And we're going to call it mosquitoes. This is going to be called pickup mosquitoes. And just like we did with puppies, we want to inherit from pickup base, not mono behavior. We're going to use the override keyword. And we're going to override do pickup. We're going to override do pickup. And we don't actually want this to be destroyed. So let's see, what do we want it to do? All right, so we're going to do a debug log, and we're going to be like, oh, we're being eaten alive. And then we're going to also change our player character's color to show that he's been infected or something. Being eaten alive. Afterwards, we want to change the character's color, and we'll choose red. So we have our game object, because remember, we're passing in the player. Let's get the component. We're going to need the renderer in order to change the material. Not the render buffer, we want the renderer. Now we want to get the material. We want to set the color. And that takes in 2 parameters. The first one is the name of the parameter we're going to be changing. And remember, with Unity, it's not color, it's underscore color. And we want the color that we're going to use. And I believe we want to use red, so let's use color dot red. So let's go ahead and save that. Now let's create. Sorry about that. Let's go ahead and create another object. Oh, wrong menu. Just do it here. We'll make another cube. We're going to make it bigger. Going to have a swarm of mosquitoes. Put that on there. And we also need to put this script on there to make sure that it will actually work. And important, we need to make this a trigger. Let's just move this down into the world. We'll put it over here, far away from our puppies. No problem. Eric said, I'm sorry, I still have Unreal in my head. It's not bad to have Unreal in your head. All right, so let me go ahead and open up the console. Now, click into the game view. So, I'm being eaten alive, and as you see, it does turn my player character red. And interact with the puppy, it says playing with puppies, and the puppies disappeared. So, as you can see, we have two scripts, pick up puppies and pick up mosquitoes, that both inherit from base pickup. And each one does something that is unique. So let me go ahead over my notes to make sure I covered everything I wanted to cover. All right, so one of the things I wanted to cover is the polymorphism. That's over here. So we can use that on pick up puppies. Let's go ahead and put in a breakpoint. No, here. Let's see, we'll do it on both. I'll do it on pick up puppies, and then I'll show you on pick up mosquitoes. I'll do pick up mosquitoes first because I think it's going to be a better example. And we'll put in our breakpoint in our base pickup. We'll do it here. Let me attach it to Unity so we actually get this breakpoint. Got to click in the game. So as you can see, we're here. It's calling do pickup. Now, normally, if this was just a normal, I have all these wwws. Normally speaking, if this was any other type of script, right, do pickup should call this do pickup and it should just destroy the object. But when we go ahead and step into, you'll notice that it goes over here into the pickup mosquito and it does the do pickup that's here in mosquito. Now, this is because we have this virtual keyword, and that's adding this function do pickup to this virtual table that C# will have. And basically, it goes down this list of virtual functions, and it determines which one to use for that object. And since this one actually has a do pickup, it will do whatever is in these brackets for the do pickup. And that's polymorphism in a nutshell. All right. Are there any questions on inheritance, polymorphism, or overriding? And you can actually raise your hand, I'll unmute you, and then you can ask the question. All right, so I'm going to assume there aren't any questions on inheritance, polymorphism, and overriding. Pretty straightforward concepts. Most of this you've sort of seen at least once when back in PGF2 in the Unreal projects. So we'll move on to interfaces. Now, interfaces is something that you've been exposed to in the past. On PGF2, we had a bunch of interfaces that we used, but you may not have seen it here in Unity. Let's stop this. Let me get rid of the breakpoint so it doesn't bother us anymore. Stop here. So we're going to make an interface and we'll just call it, okay, I see something. Nope, nothing. We're going to make an interface and we'll call it iActivate. So let's create C# script. We're going to call it iActivate. So now when we open up the script, you'll notice that it looks like every other one, right? It says public class iActivate mono behavior, and it is a child of a mono behavior. It also has update and start, which just come with all of our scripts when we make them. We don't want any of that. This is an interface. Now to make an interface, we use the keyword interface. And it's going to be called iActivate. Now, one of the things you should note is that this name doesn't have to match what the script name is, because we're never going to attach an interface to an object. So the rule of the names matching doesn't apply to interfaces. I still do it just because I'm in the habit of making sure all my names match. But for interfaces, you actually don't have to. So if you remember back in PGF2, when we created an interface, all we could do is define what the method name would be. All right, so we can't declare any variables, and I'll show you that. All right, I'm gonna have to mute you, Eric. Sorry about that. So we can't actually declare an integer. So I'll try to int I equals 5. And if you hover over it, you'll see like there's a little red squiggly here, and it tells you interfaces cannot contain instance fields. We can't do that here. Another thing, let's go ahead and define a function or a method. And we'll call it doAction. If we actually try to create the body for it, we'll get an error. And it says target runtime doesn't support interface implementation. Yeah, so we can't actually implement the method here on an interface. All we can do is define it. The implementation will take place wherever we're using it. So right now, I'm just going to define one. It's called do action. The return type is void. We don't actually want to return anything. So now I want to have a projectile that's going to interact with my pickup objects, and that's going to actually use the interface. So in order to do that, first thing that I have to do is actually create the projectile. So let's go back here and what's this cube? See, I forgot to name that. This should actually be mosquitoes. I see something. Oh, no problem. I understand things. You might have accidentally hit the unmute button. No problem. So let's go ahead and we're going to create a projectile. We're just going to use this spear for this. It's going to be projectile. It's going to be a trigger because we don't want it to collide with we don't want it to stop things from moving around it. We'll leave it like that, and I will want to actually put the projectile script on it, which I haven't created yet. So let's create the script. Call this projectile script. No, Unity, open up. I want this. All right, so projectile script. That's going to go ahead. That's going to extend from mono behavior. And let's go back in here. Let's make sure that projectile script actually does exist on the projectile. And one of the things I want to do with the projectile is I want to create a prefab. So let me go ahead and create a new folder. I like to organize things. Prefabs. And we'll make it a prefab. I'm not going to want it in the level. I will be actually creating it or instancing it when I hit a button. I think I'll use the space bar. So when I'm moving my character around and I hit the space bar, he'll shoot out one of these projectiles. But for right now, before we get to that part, we need to create the functionality for the projectile. Now, when the projectile is fired, it's going to need to move. So let's go up here in our fields, and we're going to create another serialized field. And this is also going to be this is just going to be speed, how fast our projectile is going to move. Let's see, I believe our character was moving 7, so let's try 9 as our default. Now, since it's a serialized field, we'll be able to change it in Unity. So don't we need anything on start, so let's just get rid of start. On update, I am going to want to move. All right, so I want to move 9 units every second, not every frame. So remember that update, this method gets called every frame. So if I just did this, transform.position equals transform.forward, because we want to shoot it in front of us. And if I just did times speed, every frame, so remember frames happen very fast, depends on the computer speed, but every frame, it'll move 9 units every frame, which means if we tried this, well, can't right now. I haven't done any of the coding for shooting it. But if I did this just like this, you probably wouldn't see it on screen. You'd probably hit spacebar and it would just render off screen because every frame, it would have drawn it 9 units away. So by the time it got on a slower computer, if you were getting 60 frames a second, it would have moved it 60 times 9 units in the forward direction. So we actually want this to be 9 units a second, not every frame. So to do that, we're going to use a built-in function, a built-in method in Unity. Actually, I believe this is in C#, time.delta time. So that will make it so that this will move 9 units every second. Now, when it collides with something, we want it to tell that something we want to use the interface to tell that something to do something. So that sounds a bit confusing. So whenever our projectile hits one of our base pickups, we want to, through our interface, call the do action. So let's go ahead and start writing out the code for that. That's going to be on trigger. So first thing that I want to do, I'm going to put in a debug, just to make sure that I want to get the name of whatever it is that we're colliding with. And for right now, let's start with that. Okay, to get the name, we're just going to use the other. We're going to use name. So whenever we shoot something, right now, we're just getting their name. So let's actually get shooting working. That's going to be here in the player script. So right now we have all the movement stuff. And what we're going to do now is we're going to check for the input, the space bar. And remember, to do that, we're going to use an if statement. Input.getKeyDown. Get key down. There it is. Now we're checking for, I said it's going to be space, so key code. I somehow got misplaced there. It's key code. And I'm using space. So whenever we hit the space bar, we want to instance, so we'll use this instantiate. So when we hover over it, it tells you what instantiate wants. We want an object, a vector, and a quaternion. So we want the object that we need to spawn, the position we want to spawn it from, and the rotation that it should spawn from. So the object itself is going to be projectile, but right now we don't know what that is. So we're going to have to get a reference to that. And the easiest method right now, we'll just use a serialized field. Now this is going to be a game object, capital G, because this is a class. We're going to call it projectile. By default, we want to set it to null. That way we just don't get the warning. So let me go ahead and comment this out. That way I don't get the error. We're going to go back to Unity. Now our player, let's go ahead and play. I have a compiler error going on over here because I have an if statement that doesn't have anything inside of it. So for right now, we're just going to debug log. I'll comment that out later, but we're just gonna say space bar press. Let's go back in here. So we have this projectile. That's the variable that we created, and here's the serialized field. So what I'm gonna do right now is go into my prefabs, move projectiles in there. So now we have a reference to the object. So now let's comment this out because I don't need the debug log there. So remember that in this, we actually want the object. So our object is called projectile. And we want the player's transform that position because we want to fire it from our player. And it might help if I spell transform right. We're going to use the player's position. We're also going to use the player's rotation. So let's go ahead and test this out and make sure that it's working. So right now, I see a clone, but I do not see where it's firing. So let's go back and take a look to see what's going on. And also, I think I want a better color for this. We'll create another material. I'm going to use Control D to just duplicate this material. I'm going to rename it. I will call this projectile. I don't want to use that red. Let's go ahead and we haven't used magenta, have we? So we'll just use magenta. Let's see, add component, we want a material. Actually, can I just replace you? Yeah. Should be under rendering, material. Yeah. Just add it on there. Let me go ahead and play it to see if it's actually spawning somewhere and I'm just not seeing it. Here. So it is spawning over here. That's not where we want it to spawn from. So let's go figure out why that's happening. This is all happening in the player script. So instantiate, we want the projectile. I'll transform that position and transform that rotation. Yeah, so that should be fine. No. Projectile script, let's take a look at that. That should be fine. Maybe it's too fast. But we are using time.delta time and it should be coming from our players. Ah, that's what it is. So over here, I am setting its transform position equal to this. So that's just automatically putting it into it. What I want to do is plus equals. I want to add to its current position, not set its position. That's why it's just jumping over to the left of the screen. So now now we should see, so we're shooting. And let's see, let's go to our console. As you can see, it says that it collided with the nav agent, so it collides with the nav agent. Collided with the player, it's always going to collide with the player because of where it's starting. It should be saying that it collides with our mosquito. Maybe it is, and that's up here further. Nope. So let's see if it does it with our puppies and our nav agent. So it did it with our nav agent. All right, so it's colliding with, it's just showing the player. It should also show, yeah. So you'll notice that it's not colliding with my mosquitoes and it's not colliding with puppies. And the reason for that is just the way that triggers work. I believe that they've gone over it last week. Two triggers going over each other isn't going to cause a collision. It's just going to ignore it. Now, the way for me to fix that is going back into my projectile. Let's go into my prefab. So inside of my prefab, what I want to do is I want to add a rigid body. There it is. So now let's test it again. It should now be detecting not another collider, because a collider and a collider, yeah, just add the rigid body and it should work. Because that'll, yeah, as you can see, it collided with mosquitoes. And let me check with puppies. It should also do it with puppies. And there's path blocker, base object. Is it going over? Let's take a look. Let's get in here. I didn't name it puppies. That's why it's not coming up with the name. This is why it's important to name everything, guys. So it is actually saying it, collided with base pickup. The reason it doesn't say puppies is because I forgot to name this puppies. Now when I test it, it should register puppies. So let me go back to the projectile real quick. I just want to check a couple other settings to make sure I got them correct. Leaving the rigid body, I want to use is kinematic. So what I did to get this projectile, which is a trigger, in order to get it to interact with other objects that are triggers, I added the rigid body. And I'm just checking is kinematic because I don't want physics to really play around with the bullet. I don't want it to have any effect on the bullet. Okay, so now I can actually shoot objects, and I'm getting a reference to the object, and I can tell that because in our script, we are getting the others.name in our projectile script. All right, so I know that I have access to this other. Now, what I want to do is I'm going to want to use this interface that I created, do action, in order to have my mosquitoes and my puppies, and I'll even have the nav agent do something with do pickup. So first things first, let's start with puppies. Now, if we, the hierarchy here, so pickup puppies inherits from pickup, you can only ever inherit from one thing. So if I try to inherit from pickup and let's say mono behavior, like it allows me to type it out, but this is, as you can see, you get this error. And the reason for that is you can only ever inherit from one parent. So we can't do that. Now, interfaces do not work the same way. In order to add this interface, just use the comma and we type out the interface's name, I activate. Now, you'll see that we still have this error. And when we read this error, it shows you pickup puppies does not implement interface member iActivate.doAction. So it's complaining because we have this method do action, but we haven't actually used it in the pickup puppies. So let's just go ahead and show potential fixes and we'll implement from the interface. And it'll just put down public void do action. And it gives us this throw new system dot not implemented exception. This is just going to throw up a little debug log stuff for you, letting you know that nothing is happening in this class. But that's not what we want. We actually want the puppies to do something. So let's see, what do I want the puppies to do? I think that when we shoot at the puppies, I want the puppies to move. I don't want the puppies to die because I don't want to kill puppies, but I do want it to move. So I will have it move, we'll just have it move to the left. So let's start real quick. Transform, we want its position, and we're going to subtract minus equals transform dot right. That's by default is only gonna, the transform right is only gonna give us a value between 1 and -1, but I want it to move, let's have it move 5 units. So I'm just gonna multiply the transform dot right by 5. So now when I shoot the puppy, let's see, when I shoot the puppy, I want it to move to the right, and this method here will do that. However, right now, the only thing I'm telling the projectile to do is to write out the name. So in order for me to actually use this method on pickup puppies, this do action, when I collide with it, I need to see if I activate actually exist on the pickup puppy. And if it does, then at that time, I want to call do action. And the reason I'm doing that check is if I don't do it and I hit something like the nav agent and I call do action on the nav agent, I'll get a null reference exception because because do action doesn't actually exist on a nav mesh agent. Okay, hold on, there was a question. Can't we use the child do pickup to destroy it? Do pickup isn't in a child. Do pickup actually belongs to this I activate interface. All right. So the question is, could we use, let me see if I get your question correct, Thomas. Could we use do activate to destroy the puppies? We could. All right. In order to do that and pick up puppies underneath the do action, we would just destroy the game object. That would, when we call do action, it would destroy the puppies. It wouldn't do the base do pickup because do pickup is actually a method that was defined here in base pickup. And we modified here in puppies. So yeah, so with the projectiles, we are actually going to be using, we're going to be calling the interface, which is, again, the method for the interface is do action. So we're going to be calling that. And so far, what we're going to do is just have the puppies move 5 units to the left. Now, in order to do that, we actually have to invoke that interface. And there's several things that we're going to have to do beforehand to do that. Since we know we can get the other we have whatever we collided with, we're going to check to see if it actually has the iActivate on it. So to do that, we'll use the get component. We're checking for iActivate. And great, that gets it, but we want to actually check it, so we'll put this in an if statement. Now in an if statement, hitting the wrong buttons, sorry about that. The if statement, we actually have to check for something. All right, if I just did this, this will give me back, it'll give me back the iActivate, or it'll give me back null. So I want to check to make sure that it's not null. It's not equal to null. That means if this object that I am colliding with actually has an iActivate on it, then we can do something. So I'm going to make a body. I'm going to declare another variable of type iActivate, and we're just going to call it A. We're going to set that equal to other.getComponent iActivate. So now we stored the reference to this iActivate, and we put it into this variable called A. Now what we're going to do is A.doAction. So now when our projectile collides with a puppy, the puppy should, if everything's working right, move to the left 5 units. So let's play. And let's shoot the puppy. So that didn't do it. So let's check why. Got player, let's see. Got the player object, got a path blocker. I didn't actually get the puppy. So one of the things I'm going to do, because it seems like I might be missing this, I'm going to move this over onto this side. I'm going to make it bigger, just to make sure that I'm actually colliding with it, because I didn't see its name come up. So it did collide with the puppies, but the puppies didn't actually move. So let's check to see what's going on there. Let's go back to our script. So over here, let's see. No, nobody guessed it yet, but over here, I have this get component iActivate, but I'm not checking what object am I checking? What I want is the other object. I want other.getComponent. So I can grab whatever it is that I'm hitting, because I get it here, right? I want to see if that has the iActivate on it. So as you can see, every time that I shoot it, it'll move over to the left 5 units. And again, that's being handled through the interface. So let's go ahead and do something with the mosquitoes. I'm going to make it so that if I shoot the mosquitoes, the object itself, this cube, is going to shrink. So I'm killing some of these mosquitoes. The swarm is getting cold. So let's go ahead and over to pick up mosquitoes. And again, we want to add the interface to this. To do that, we go put the comma after the parent class, and we type in the interface. That's iActivate. It's always going to complain until we actually implement the method that is in the interface. And I just always do it this way, because why should I type it out when the computer will do it for me? We don't need it to throw the exception. So what I want it to do is I want to get the scale and I want the scale to shrink. So let's go ahead and do that. So transform, I believe it's local scale. I'm going to do times equal, and I am going to do a 0.5. So I want it to shrink in half when I shoot it. So now when I shoot the mosquito, it should do this. So let's go ahead and take a look and make sure that's working. If not, we'll figure out why. So there you go. Every time that it hit it, and it registered more hits than just one. It hit it 3 times. So it scaled it in half each time. So, and do notice that the code didn't change as far as my projectile script. Right, I have it coded so that it looks to see if I activate exist on the object that I'm hitting. And if it does, then it just tells it to do the action. So let's do something with nav point. Yeah, go ahead and fix it. So remember, our nav points, they don't have anything that they're doing. They're just empty. They're used basically as something to check, something for the nav agent to check to see if it hit. So we're going to add that interface to it. I activate. Do the work for me. So here, I'm going to want to do something very similar to what the puppies did, except I'll probably have it move in the positive direction. So transform that position plus equals transform that right. And I'm just going to multiply that by, for right now, I'm just going to use 3. So now when I hit a nav point, it should move over 3 units. See if I can get to this quicker. Maybe not. Am I not hitting it? Yeah, it's too far down. Looks like yeah. All right, so my projectiles are too small. So what I'll do instead is I'm going to take all of these, try to move them up a bit, maybe scale them up a bit so that I can actually make sure my projectile hits them. Just do 3. Hopefully my projectiles will now hit them. That one looks like it's going to be too high. Whatever, just want one of them. So, and you'll notice that this is a little bug now. This guy here, he never reached the nav point because I moved it and he already has a set destination to get to. So we'll look at ways to fix that on Wednesday. Looks like we're going a little bit long and I need to get to some other topics beforehand, but we could make our nav mesh or nav agent a little bit smarter, because right now what's going on is that when we find this destination, it gets the destination that it's going to, and it looks for an on trigger enter. So because it's not actually hitting it, it won't move to the next destination. So there's things that we can do to fix that, but right now it'll take us a little bit too much time, and we're already running into about an hour and 15 minutes. And I still got to go over namespaces. So I apologize for that. We could definitely cover it either in tonight's lab or in on Wednesday's lecture. So the last thing I need to, interfaces. Are there any questions on interfaces so far? I'm going to take the silence as there are no questions on interfaces so far. So, all right, so now we're going to move on to namespaces. And we've been using namespaces. Believe to get the nav agent to work, you were using unityengine.ai. Just take a look. Yep. So, this is a namespace. So right now we're going to go over how to make our own namespace if we wanted to make our own namespace. So we're going to make base pickup our own namespace. So to do that, all we're going to do is use the keyword namespace. We're going to call these pickups. And we want to put those in curly brackets. Curly brackets. So now, save that. Now, all of this exists in this namespace called pickups. Now, one of the things you're going to see is in puppies, we have a bunch of errors. And in mosquitoes, we have a bunch of errors. That's because this parent class pickup base exists in a namespace called pickups. But our script right now doesn't have access to the namespace pickups. Now we can do what we did before, use the using keyword here and put in pickups. And you'll see the errors get put away, or get resolved. Because now this class, pickup puppies, has access to the namespace pickups. Another thing we can do here, since it's only on this one line, we can use pickups. Pickups.pickup. Now what this does is specifying the namespace and then the base class. Right. So these are two ways that you can access the namespace. Now another thing that I want to show you about namespaces is that we'll get rid of this real quick. So the errors will come back, but bear with me for a second. We can add different or separate scripts to the same namespace. And to do that, we just use namespace, and we just make sure that we use the same namespace that we'd used before. And again, we have to encapsulate it in these curly braces. So now, whenever we use that using keyword, so if we went here to pick up mosquitoes, let's get rid of this. Make sure I save puppies. So now pickup puppies and pickup base both exist in this namespace that we created called pickups. So here, we went here using pickups. Now our pickup mosquitoes have access to everything that exists here in pickup base and everything that exists in pickup puppies. So, and this could be useful when you are setting up your game projects and you want to have certain code only have access to this particular code. All right, so like if you have code that you don't want the player or the enemy characters to have access to the code that the player character is using or some of the stuff that he's using. Because remember, with all code, if it's just open and part of the project, it's gonna run and it's gonna compile. For optimization purposes and just to save cycles and sanity, you only want the code to run when it really needs to run. So if you have code that only the player character actually needs to run this, you can put that in its own namespace and give the player access to that namespace. And then you can have your enemies not have access to that namespace, so they don't actually have to compile any of that code that's for the player when they're running, right? And let's think about it in an actual game. We usually have 5 or 6 enemies on screen. So every one of those enemies would be running all of that code in the background, right? So if we can eliminate what code it actually needs to run, it frees up space for us to use for other cool things that we can do. So that's it for namespaces. They're pretty straightforward. You just use the keyword namespace, space, give it a name, and make sure that everything in that class is inside of a body for the namespace. And now it's in a namespace. And the other thing to take away from it is that it doesn't have to exist in one script. That namespace could actually have methods and functions that exist in separate scripts. And that still will all come up underneath that namespace. So that's it for today's lecture. If you have any questions, now would be the time to ask them. All right, so I'm going to assume that there are no questions right now. I am going to stop the video recording. If you guys do have other questions and you're just uncomfortable about asking them while being recorded, feel free to ask me after I stop recording or ping me on Discord. Thank you guys for attending the lecture.